Yes, class, am I audible to you? Ahmed and Shakina. Okay, Ahmed. Shakina, I hope I'm audible to you.
Yes, ma'am.
All right. See, Sakina, one thing. In this, we are towards the end of the lesson. So just few minutes will be taken where we'll be discussing whatever portions of semiconductors will, which was left last weekend. So that we'll be completing right now. So some things will maybe there that you'll not be able to understand. So just have patience. After we complete with this, then we'll start the entire syllabus throughout with proper theory also, as well as revision of the numericals part also. So just revise it also. That will become a revision for you. And then we'll move on to the revision part directly. So many students have had this part. One part that we had to discuss was how to identify forward and reverse. So see how you people identify forward and reverse biasing is by identification of PN junction. See if the P type is connected to the positive terminal of battery and N type to negative terminal, that we call it as forward. And when we say P type is connected to negative terminal of battery and N to positive, we say that is reverse biasing. This much we all have studied. So some students have studied this part, how to identify forward and reverse, and some students part was left. So like Donna and all, you have attended this class. So just have patience. After a few minutes, we'll start with this. Who has joined in here with the name? Okay, Fahad. Oh, all right, Fahad. So see, so many of you, I have discussed it in the last class also with you, and some of you, this is new for you. When the P type is connected to the higher voltage, higher potential, and N is connected to the lower potential, we call it as forward biasing. Like here in this case, P type is connected to the higher one, and this is the lower one. So we'll call it as forward biased. And when the opposite will occur, like look at the third example. P is connected to the lower one, N is connected to the higher one. So when N is connected to higher, P to lower, we call it as reverse biasing. So this is the case, how to identify. See the numerical fifth. This is earthing symbol, that is potential has become 0. And here the voltage is 5 volt. So 5 volt is obviously greater than 0 volt. So P is connected to higher, N is connected to lower. So we'll call this as forward. What we need for forward biased? P to be connected to the higher one and N type to be connected to the lower one. This is what we require for forward biasing. Just remember one thing, then reverse it for the other one. Like for N type, reverse it. When you want to find out for reverse biasing, no, reverse this. N will be for higher and P will be for lower. How you identify. All right. So rest of the examples are also similar. Those who have not noted, you can note down this. This is just higher and lower connect. So yes, those who have joined just now, how do we identify forward and reverse biasing when it is not just easily identifiable by just looking at the cells? So P type is connected to the higher voltage, N type is connected to lower voltage. We call it as forward biasing. And when the reverse happens, yes, not first and second part, I am planning, because you all have done, everyone, all of you have recently covered modern physics, and that is a very small unit. So I'm thinking let us start with the revision. I'll do as per you all people will be convenient with, I think, but we should start with the revision after this. This is just we are revising. Some of the students have not attended this part, so that we are completing. After that, Fahad, we'll be starting with the revision of modern physics, because that will clear one unit first, and that is a smaller unit, and most of the questions are from there only. So all the previous year's question plus that, we'll first try to complete modern physics and second book, because that you people have done recently, so you do not have to study much and pay much attention to the previous part. Otherwise, for electrostatics and rest of the lessons, what will happen? we'll all have to revise it from the scratch, right? So that's why it's better if we start with modern physics. Otherwise, if all of you want to start with chapter 1 and 2, no, that's okay, Faz. I'll do the whole entire theory part. Don't worry about it. I'll do the entire theory part. Then we'll be doing the numericals accordingly. All the previous year's questions and main important questions. Yes, done this part, others. Now, one more thing is there. See, if these diodes are connected into the circuit, again, I'm repeating for those who have just joined. So students like Fahad, Dona, and Rufia, all of you just pay attention. Just have patience, and after a while when we'll revise this part, which you all have had that in the earlier class, then we'll start with the revision. Same with goes for Sakina. So yes, if these diodes are connected in a circuit, now see what will happen. If you are able to identify whether it is forward reverse, then your entire physics will be exactly as that of current electricity. Like we discussed it, if diodes are forward biased, like this, diodes are forward biased, then you just replace the diode with a single wire. So you know what will happen. If you replace it with a single wire, means lots of current and can flow. So that means you have short circuited. And if you are able to identify that, yes, this is a reverse bias by just looking at the terminals or just by identifying the voltage, that means it is open circuit. It means you can easily remove the diode as if the diode is not present. This can be easily demonstrated through this question I had discussed in another class. See, this diode P type is connected to the positive terminal, N type is connected to the negative terminal. This means this is forward. Whereas this N type is connected to the positive and P type is connected to the negative. That shows this is reversed biased. So if this is forward, this is reversed. What did I tell you all? Forward, replace it with a single wire. See, here was the diode. I have replaced it with a single wire and remove the reverse bias style because this is open circuit. No current will be flowing there, right? So no current is present here. It means this is just your circuit now. Now you know how to solve this. Whether equivalent resistance is asked, a capacitor is connected, inductor is connected, AC circuit has been formed. Now you all people know how to solve all the questions of AC, DC, whether it's just a direct question from current electricity. So diodes, do not get confused if you have diodes, and the circuits, if diode is present, that is very easy circuit. You just have to identify forward and reverse. Apart from this, two graphs you have to see. Forward bias and reverse bias we all have studied, right? So here what you have to do, if you get a question where you have to draw or plot the graph of forward bias, so what you will do, in both the graphs, what happens is, see, this is the graph of forward bias. Some students already know this. For some students, this is new. Current versus voltage, if you draw, what happens? Current linearly increases. Current linearly increases up to a point. Fine. Then current increases up to a point at a certain voltage. After this, it increases abruptly. Fine. Current increases linearly the way it obeys Ohm's law. Whatever Ohm's law we have studied, no, potential is directly proportional to current applied across the terminals of the cell. So current is proportional to voltage. If current increases by 2 amperes, voltage will also double itself, but at a point only. Then the current suddenly increases. Abruptly, the current increases. Fine, the current suddenly increases. So this type of graph, we get it for forward bias, and this value of voltage, which you will obtain after which current abruptly increases. This value, this is known as knee voltage. Same case is that for the reverse biasing, but just that we draw it in the third quadrant here. This quadrant we draw it. So current increases, and then suddenly a value comes where the current's value increases so much. Means increases in the negative sense. It becomes more negative. You don't have to do the details of all these because all the Zener diodes and rest of the circuits have been deleted from your syllabus. So just know, if you are asked to plot the graph of reverse or forward, just plot these two graphs. Again, here also there is certain value of voltage, this value of voltage at which the current is abruptly increasing. So we call this as breakdown voltage. So knee voltage, we call it for forward bias, and breakdown voltage, we call it for reverse bias. That's all what you all have to do, what you all have to remember. Rest of the parts we'll be doing in the questions. Let us first complete 1 or 2 classes. Let us check and thoroughly let us revise modern physics, do it properly. Then we'll do the questions, more questions on semiconductors. Some questions we have already done, some more questions we do. So some of you have, those who have not written this part, you can note it down, take the screenshot or note it down in your notebook. Then after 5 to 10 minutes, we'll start with the revision of modern physics. So we'll start with modern physics. If anybody has any issue, then let me know. Otherwise, I'll start with 1 and 2. But I think since we all have done modern physics recently, so it's better if we start with dual nature, atoms and nuclei, as these lessons are also very short, right? So I think we'll start with the revision of modern physics only, all the previous year questions. And obviously not in one class, it will be over. Next Saturday also, we'll have to use it. And those who are still writing down, please keep on texting me done in the chat column so that I can get update of what you all have written.
Ma'am?
Yes, Astha.
Ma'am, could you send the notes of modern physics again in the group? I couldn't find it.
Okay. Yes. I'll resend it right now. And semiconductors link also I'll share. No, I haven't not sent you the link of semiconductors, right, class? I think till wave optics only I've sent, no?
Yes, ma'am. Till wave optics, it's there. After
Till
that.
wave is there. So modern physics entire written notes is there. So you can refer that, and semiconductors I'll share. Semiconductors link I'll share. This one is for forward biasing. See, Fahad, knee voltage means knee voltage. One more thing, class. Knee voltage can also be known as threshold voltage or cut-in voltage, right? So here, what happens initially, the current increases very slowly, almost negligibly. So till the voltage across the diode crosses a certain value, this certain value, this is known as threshold voltage, knee voltage, cut-in voltage, all these names are given. So value, this certain value, like I'll give you an example for germanium diode, it is 0.2 volt. Unless and until 0.2 voltage is reached for germanium diode, then only the current will increase. Otherwise, before that, no, let's say 0.1 volt, 0.19 volt, or 0.06 voltage, like these values, the current will be increasing so much slowly that you'll not be able to, it increases, yes, it increases suddenly. The value will increase suddenly. Initially also, it will also be increasing. Before knee voltage also, it will be increasing. But the increment will be very slow. So after knee voltage, it will increase abruptly. Exponentially is the right word exactly. So diode current increases rapidly, exponentially, even for a very small increase in the diode bias voltage. Fine. So here what happens? Basically, majority charge carriers feel negligible resistance at the junction. And resistance is also quite low. So that's why this term knee voltage is given for it. And same work it is done for the breakdown voltage. That is the Zener voltage. This is for the reverse one. So quickly write it, text me done. All of you, those who are writing, then we'll start with dual nature. So most of you have completed. Is there anyone writing?
No, ma'am.
Done, no? By all of you. All right. C class, let us start with the revision of modern physics. Okay, Ma, let me just wait for 1 more minute. Then I'll start. Okay. C class, let's start with this unit, modern physics, and we'll be first completing dual nature of radiation and matter. Now, C class, this is also an important lesson. All the 3 lessons of modern physics unit is very easy to score. And even if you look at the questions that have come in your previous years, all are of based on same patterns. Most of them are similar type of questions. So we'll try to cover all the types of questions that have come. But theory part is also important from this. Like most of the lessons, like current electricity, if you have, let's talk about current electricity if you have. So from there, or wave optics. So such lessons have more of the numericals part to be covered. Here, in case of modern physics, you have more of theory portion involved. You have more portion of theory involved. So here, the first thing that you have to remember is that 4 types of emissions occur. See, when electrons are present in the metal surfaces. Yes, numericals will be there. Numericals will be there. In your 1 marker, numericals will be there. 1 marker also numericals will be there from your proper 3 marker, 2 marker also. So numericals will be in 1 marker also, and even your theory part. And it's the ratio is not such that somewhere it happens that the theory mark question can also be more. So it's not fixed as if numericals come more in board exam in totality. If you talk about, if you're talking about a single lesson, like if I talk about this lesson, then I talk about atoms, then I nuclei, then I can compare that yes, from this theory part can come more like this. But in general, anything can happen. Anything can be asked. All right. So yes, what I was saying, yeah. So metal surface is there. Metal surface is having electrons. Metal surface is having positive ions. All right. So these electrons, which we call as the free electrons, they can be made free. These electrons can be made free by 4 methods. So these 4 methods, all of us have discussed it. But class, these 4 methods, remembering all the 4 methods is not very important. I'm again telling this, because nobody is going to ask you each method in detail. But let us just discuss. See, when a metal is heated, its free electrons get sufficient thermal energy and they can overcome the surface barrier. So that thermal energy will when the electron will be emitted, it will be called as thermionic emission because of thermal energy, right? Then you have cold cathode emission, which is written as field emission or field energy emission. Their high electric fields are applied on the metal surface, like 10 to the power 3, 10 to the power 8, such volt per meter amount of electric fields are applied. So when the electrons are that time ejected, we call it as field energy emission or cold cathode emission. All right. Then we have third type, which is by moving electrons. If 2 electrons, when like fast moving electrons strike a metal surface, they transfer some of the energy to the other free electrons. If 2 electrons will collide among themselves, then one of the electron can get ejected. So that we call as secondary emission. Finally, we have this most important type of emission, which we call as the photoelectric emission. This is when the metal surface electromagnetic radiations are struck. EM waves we have studied. So when electromagnetic radiations of sufficiently high frequency are incident on it, then the emitted electrons, we'll call it as photoelectrons. This entire process or emission will be photoelectric emission. So out of all the four emissions, this photoelectric emission is the most important for you. Questions will come from photoelectric emission only. These four have not even been asked ever in your previous year's questions also, the names of all these. So just focus on directly photoelectric emission. Now, what you have to remember, what is important from your numerical perspective also, class, four things you have to remember for this photoelectric emission to occur. A minimum value of energy is required. What do we call this minimum energy that is required to eject electron? Name of this energy. A certain energy is required. When that energy is met, then only electrons get ejected. So anybody who remembers this name? Threshold energy, right? So more accurate than for threshold energy, Ahmed, it will be work function. Remember work function. So see, energy, potential, frequency, and wavelength. Class C, these four things are required. These four things are required. Frequency, potential, and wavelength. These four things, energy, potential, frequency, wavelength, all these four things are required. Minimum, certain value, one minimum value of energy, one minimum value of potential, one minimum value of frequency, one minimum value of wavelength. All these minimum values are required. Then what will happen? When this minimum value of energy is crossed, when this minimum value of potential is crossed, when this minimum value of frequency, when this minimum value of wavelength is crossed, it is achieved. This is like the cutoff. When this is crossed, then only the electron will become available for ejection to occur, photoelectric emission to occur. So this minimum energy that is required for the electrons to get ejected, this is known as work function. The minimum potential that is required, this is known as cutoff potential or stopping potential. The minimum frequency that is required, this is known as threshold frequency. And the minimum wavelength that is required is known as threshold wavelength. These are all the four things that are required. Now, all of you have the notes, so no need to write. And I think only one student, Sakina, are you added on the WhatsApp group?
No, ma'am, I don't think so.
Okay, Sakina. Because the notes of these are shared on the group only. I'll get you added or I'll share the notes with you on the group only. So in the notes, everything has been written there. So others also, I'll resend it once. Fine. Now, before the variation, so these four things are there and numericals will be from these four things and theory part can also be from all these four. You can be asked to write the definition of work function, write the definition of frequency, stopping potential and wavelength. Mostly definition of threshold frequency and work function has been asked in the exam. These two have been asked a lot, work function and threshold frequency. Now then comes the experimental study of photoelectric effect. So how will you get the questions for all these graphs which we have done? So question can be describe the effect of intensity on photoelectric current, or describe the effect of potential on photoelectric current, or frequency on incident radiation on stopping potential. So these three can be asked directly to you like this. And all these graphs are important directly. These have been mentioned in your textbook. So any graph can be asked. So current versus intensity. Current is directly proportional to intensity. If you allow radiations of a fixed frequency to fall on any metal plate, then what will happen? As you will keep on increasing the intensity to certain value, you have increased intensity. Potential, the value of photoelectric current will also increase. Then again, you have increased intensity, photoelectron will also increase. So as the number of photoelectrons will keep on getting ejected, that will be directly proportional to intensity. If you increase the intensity, amount of photoelectrons released will be more. So photoelectric current will be more because ultimately these photoelectrons are only making up your current. So that's why we have a linear relationship. So you directly draw this graph. Photoelectric current is directly proportional to the intensity of incident radiation or current, or you can say photoelectrons are also directly proportional to intensity of the incident radiation. Secondly, you have effect of potential. So definition is very easy, minimum potential that is required to achieve. Now, just focus on the graph right now. Rest of the part that we'll see in numericals. Once we'll start with numericals, let us just see this theory parts of it. So in effect of potential, what happens? If you keep the intensity and frequency of incident radiation fixed, frequency will keep fixed, intensity we are varying it. So what happens? You increase the positive potential or accelerating potential. It is found that photoelectric current increases with the increasing potential. Look here, photoelectric, just look at the I1 graph. Forget about I2 and I3 right now. Here what will happen? Photoelectric current increases with the increasing accelerating potential till a stage is reached when the photoelectric current becomes maximum. See, now no more amount of increment is there in the current, and it does not increase further with the increase in the accelerating potential. And we call this maximum value of current that is achieved as saturation current. So this is how you plot the graph. Now, if you increase the intensity, same shape you will observe. It's just that value of current will be more because photoelectric current depends on intensity. So if you increase intensity, amount of current will also increase. Again, let's increase the intensity. So this will also be increasing. Again, if you will add more amount of intensities like this, you will be getting graphs. Same graphs you will have, which will be I4, and I4 will be the highest. Class, one question that came in one of the in one of the papers was same graph was given without this. This was given and it was asked to write a relationship between I3, I2 and I1. So it becomes confusing whether I1 was more, I3 or I3 was more. So remember, if photoelectric current here is more, then I3 will obviously be more because you have the direct relation. So this can be asked to you to write about this relation, to mention this point. This can be asked to you. Same graph can be given or vice versa. Proper graph plotting can also be done. Then finally, you have the effect of frequency. This graph you have. If you are asked particularly to draw the graph, then you can draw the graph. Otherwise, just mention. Sometimes theory part is also asked, but it's better if even in it is asked in the theory part also, you draw the graph by yourself. That will make you be on the safer side. Now, effect of frequency. This is the third graph, which is very important. So here what happens to whenever you study the frequency, intensity is kept fixed. The way when we were studying intensity, frequency was kept fixed. So here when you study effect of intensity, frequency, you keep intensity fixed. Number one thing, fine, intensity of incident radiation at every frequency, this is kept fixed. Then what has happened? Potential on the plate, whatever plate or metal surface you have taken, this is gradually reduced to 0. Right? And then it is increased. So it increases, this increases, potential increases, and it reaches the negative value. And we know this negative value is known as stopping potential or the cutoff potential. Then it is repeated with different frequencies. So here what is happening? The graph is reverse. Graph does not start from here. The graph is in reverse manner. Here intensity of radiation of saturation current is same each time. Now potential on this plate, on this metal surface, this is gradually reduced to 0. See here, this is reduced to 0, then again decreasing, and here you're obtaining negative potential. Even if you look at from here, same graph you will get, but since intensity is fixed, the value of current that you will be obtaining will be the same. Values of all the current will be same. Yes, saturation current means maximum value of photoelectrode current, right? Means now the current cannot increase more than this value. Whatever you have received, this saturation current value, now the current cannot increase. So the saturation current is different for every metal. Like let's say for some metal, yeah, for copper, value of saturation current will be something. For other metal, let's say zinc, yes, current value is fixed, saturation current values. Good. All right, so these three graphs are very important. These three graphs can be separately asked. Mostly they are asked in 3-marker question, 1 mark for each graph, like this. Then these two graphs are important also, but they are not part of that. Usually the question will come effect of all these. Here you don't have effect on the photoelectric current. This is just an independent relation between kinetic energy frequency and kinetic energy intensity. So threshold frequencies definition I have told you all. Kinetic energy and frequency, same relation is there, that it increases directly proportional. It is linearly proportional, and it increases with the increase in frequency. If frequency doubles, kinetic energy will double. So such type of questions can also be asked to you. What will happen to the kinetic energy of the moving electrons if the frequency is tripled? So you will write it. Kinetic energy will also be tripled. Why? Because they are directly proportional to each other. By whatever amount frequency will increase, by the same exact amount kinetic energy will increase. Like this you will get question, or you will get question regarding kinetic energy and intensity. If intensity of the moving electrons are tripled, let's say, then what happens to the amount of kinetic energy? So in your MCQs also, all the options will be available: tripled, half, no effect, like this. So you will choose no effect. Kinetic energy and independent intensity are independent of each other. They have no relation. Even if you keep on increasing the intensity, velocity, there won't be any effect on the velocity of the moving electrons. So keep on increasing the intensity. Yes, kinetic energy also gets tripled in effect of frequency, but not in intensity. All right, not in intensity. So kinetic energy and frequency are proportional, but this is independent of intensity. This has no effect. Intensity has no effect. Whatever amount you increase intensity, velocity will remain the same. But in frequency, velocity increases. So that's why kinetic energy also increases. Not inversely proportional, it is independent. Inversely proportional would be that if intensity decreases, kinetic energy increases. That is inversely proportional. It is independent. Whatever value of intensity is there, see here in the graph. Let's say this value is some 5 joules. Here intensity is 1, 5 joules. Here intensity will be 2, still 5 joules. Here intensity will be 3, still 5 joules. So it is independent. Whatever you will increase, this is not inversely proportional. This is directly proportional. Frequency will increase. See, this is frequency increasing, kinetic energy is value. Here you increase the frequency, kinetic energy increases, like this. Then when you are asked to state the laws of photoelectric effect, these 4 laws you have to mention. Photoelectric effect is directly proportional to the intensity, the first graph which we have seen. Then second law, you will mention the definition of threshold frequency, the minimum amount of frequency which is of incident radiation below which photoelectric emission does not occur, or which is needed for the photoelectric emission to occur. Definition of threshold frequency becomes second law. That is the second law. Then third is just relation of kinetic energy, which you maximum. This is just, don't write it as just the kinetic energy. Whenever you are mentioning it in your answers, try to write it as maximum kinetic energy. Maximum kinetic energy is directly proportional to frequency, independent of intensity. And it would be best if you draw the graph as well. Finally, this is a new point which we have not discussed. That is, it's an instantaneous emission. Instantaneous emission means the time lag between the incidence of light radiation and the emission of photoelectrons. This is very small. Means within this 10 to the power minus 9 seconds, light ray strikes the metal surface and the electrons gets removed from the metal surface. So instantaneous emission. These can separately be asked to you. These can be asked to you as laws of photoelectric effect. So these laws will be, these were just given by Leonard and Millikan. So I think in NCERT, Millikan is only mentioned. No need to go about it. Just focus on the 4 laws. Then finally, you have the Einstein's photoelectric equation. So what did Einstein say? Einstein said that incident photon, when these electrons are moving, they'll be having their kinetic energy also. So because they are in motion, so velocity will be there. Once velocity is there, so kinetic energy will be there. So the total energy is just not the work function of the metal surface. Work function we have studied, no? Work function we have studied that energy will be, this minimum energy is work function. But Einstein proved that this is not just the work function that exists. For the explanation of photoelectric effect, it's not just the work function that exists. A part of energy of photon is used in liberating the energy, that is work function. But the remaining energy of the photon, that is used in imparting kinetic energy to the ejected electrons. So that's why we never say that total energy is equal to the work function, because rest of the energy which remains after the liberation of electron, after the usage of work function, if this was, let's say this is total energy, so let's say this part is work function, some amount will be left. This is kinetic energy. This is used in the form of kinetic energy. No need to read NCERT of physics for this, for modern physics, because what the notes that I've sent you, that has every point of NCERT written in the form of notes. So for modern physics, you don't need to. For EM waves, you have to. I have mentioned you already. EM waves, you have to, because that will become beneficial for you. EM waves is needed. Now, so yes, so the entire equation becomes total energy is kinetic energy maximum plus work function. Now we write the total energy as either h nu. H is the Planck's constant because your energy is directly proportional to frequency. And when you put the constant, this becomes h, which is known as the Planck's constant. Planck's constant has its value 6.67 into 10 to the power minus 34 joules seconds. 6.63 is also used. 6.6 is also used in the calculation. Minus 34 joules second. This is just a constant that comes to eliminate this proportionality sign. So E is equal to h nu. And we also know frequency can be written as velocity of light, that is speed of light c divided by wavelength. So we write it as hc by lambda. So energy can be written as h nu or hc by lambda. Then you have kinetic energy maximum. Either it can be written as normally half mv max square, or this kinetic energy maximum can be written as EV naught. E is electronic charge, V naught is the stopping potential. So stopping potential multiplied by electronic charge. Electronic charge is 1.6 into 10 to the power minus 19 coulomb. So kinetic energy can be written as half mv max square or EV naught. And ultimately you have work function. Work function is also a form of energy, but since it is a minimum value of energy, frequency will also be minimum frequency, wavelength will also be minimum wavelength. And we know that this minimum frequency is threshold frequency, minimum wavelength is threshold wavelength. So energy is h nu or hc by lambda. Minimum frequency, yes, it's the minimum frequency. Below it, if the threshold frequency is not crossed, then photoelectric emission will not occur. So energy can be written as h nu or hc by lambda. Kinetic energy can be half mv square or EV naught, and phi naught, that is work function, can be written as h nu naught by or hc by lambda. Now, apart from this equation, we'll do questions on this. Then you have one graph. This graph, mostly the plotting of the graph of this graph does not come. More than the graph, plotting of the graph, the numericals are asked on this, or to identify what is minus phi naught by E, what is the y-intercept, what is the slope of it. So in this equation, EV naught is equal to h nu minus phi naught. If we divide it by E, electronic charge, we get this V naught is equal to h by E nu minus phi naught by E. So when you compare it with the main equation, y is equal to mx plus c, you will notice that h by E, this becomes the slope, mx plus c. And this minus phi naught by e, this becomes the y-intercept. So you will plot it in the y-intercept, and since this is negative, it will go here below the origin, that is along the negative y-axis. So h by e becomes the slope. And how do we calculate slope? By using tan theta. So tan theta will be equal to h by e, and this is the slope. And the y-intercept, that will become minus phi naught by e. You will be getting values also, like let's say you will get a value minus 5. Fine, this is minus 5 and the unit will be there. And you will be asked to calculate work function. So you can multiply it by electronic charge. For you, 5 minus 5 will be equal to minus phi naught by e. Phi naught you can easily find out because you know the value of e. So such questions can also be asked to you. Mainly the numericals part is asked more from this variation of potential, stopping potential and frequency. Plotting can also be asked. Plotting can also be asked, but if plotting is asked, then you will have to show this part also. Do not just plot the graph and leave it. Explain why you are getting minus phi naught by e, why you are mentioning it over here. And do mention the slope. Then finally, the last topic which is there in this modern physics, this dual nature, is de Broglie wavelength. So de Broglie wavelength, basically these are to show you the dual nature. One nature, dual nature means one is the particle nature and other is the wave nature. So explanation of all the particle nature of electrons, that yes, electrons exhibit particle nature, that is given by your entire photoelectric emission theory. But what about the wave nature? So wave nature is given by de Broglie's wavelength. Fine. So this was given by de Broglie, and he initiated it with the energy mass relationship. The energy mass relationship, that is E is equal to mc square. So there is a complete equivalence between energy and mass, that is given by E is equal to mc square. Then you have the relation E is equal to h nu or hc by lambda. From there we get the value lambda is equal to h by mv or lambda is equal to h by p. This is known as de Broglie's wave equation. This equation which we get, this one. This you say or this you say. This is known as de Broglie's wave equation. So if wave equation will be there, either you can write it as P and then put an equal to sign and write h by mv. That will also be fine. So de Broglie's wavelength is same. Then 4 points you have to write from this equation. What all conclusions have been drawn? This is just the equation. What all conclusions can you draw from this equation? So I hope this wave is clear. Waves associated with material particles are called matter waves or de Broglie waves. More than matter waves, no, this term will be mentioned, de Broglie wave. Now see these 4 points. These 4 points. These are important. One says that according to this relation, when you see this formula, lambda is equal to h by p or lambda is equal to h by mv, you'll easily find out that lambda is inversely proportional to p. It means wavelength is inversely proportional to momentum. This means if you increase the momentum of the electrons moving, wavelength will be less. Because see what will happen if you increase the momentum, electrons will move faster. So wavelength will reduce. And if you decrease momentum, wavelength will increase. Because when you will decrease the momentum, velocity will also be decreasing, electrons will be moving slowly, so you'll be getting a longer wavelength. First point. Secondly, when you put lambda as infinite or when you put velocity as infinite, so 1 by 0 will be lambda will be infinity. It means infinity lambda cannot exist. This means only de Broglie wavelengths will exist if velocity is non-zero. Then only the value of wavelength will exist. So V is 0, lambda is infinity. This implies that waves are associated with material particles. They are only associated when they are in motion. Third point says that these are matter waves. These are known as matter waves. Why these are known as matter waves? Because particles do not have any charge, need not have any value of charge. That's why we say matter waves, or it depicts its wave characteristics. And finally, these are not EM waves. These are only associated with accelerated charge particles, not associated with EM waves. Not EM waves means all the properties of EM waves. These will not be valid. Electromagnetic waves have certain properties, no, like it travels with the speed of light. This happens in EM waves we have studied. So that does not occur. So because these are not EM waves. So this was about the theory part. Numericals, let's practice with the numericals. If you have any doubts in the theory part, still any portion you want me to repeat, let me know. Any doubts if you have any query? Let's.
Ma'am, can you just explain work function again? Just
Yes, work function. See, let's say one electron is there, and this electron has certain value of energy, which is, let's say, 5.5 electron volt. Now, what is happening? When you are giving the energy 3.4 electron volt, you are noticing that this electron is still residing in the metal surface. Then you have increased the energy. Now you have increased the energy to, let's say, 4.9 electron volt. Still you are noticing electron is not getting ejected. Then you increase the energy to 5.4 electron volt. Still you are seeing that energy, the electron is not getting ejected. But as soon as you step up into this value, 5.5 electron volt, you are noticing electron is getting ejected. When you will see, when you put the value of energy as 5.6 even, then also you are seeing that electrons are getting ejected. So it means this was needed. 5.5 electron was needed. Even 5.4 electron volt didn't work. 4.9, 3.4, rest of the values failed. It means this is the minimum value that was required, minimum value of energy for the electron to eject. We call this minimum value of energy that is required for photoelectron to eject. This is known as photoelectric emission. So this energy is known as work function. Clear?
yes, I'm clear.
Do one thing. First, you note down the question. Take 2 minutes. Send me the answers. Those will get their answers in the chat box. Then I'll discuss it with you. Yes, yes, Imad, correct answer. Last 1 minute, then I'll discuss it. Imad, by the time, try the second part.
Ma'am, I'm trying to do the second part. If you can just explain because I'm not getting the answer.
Okay, let me discuss it then. See, first part is very easy. Work function you have to find out threshold frequency. So work function, the way we have the values of normal energy, total energy, we write it as E is equal to h nu. So when it is work function energy, this will become threshold frequency. So work function is given to you. Threshold frequency is asked. So what we'll do? For the first part, work function will be equal to Planck's constant into threshold frequency. And threshold frequency is not known to us. Yes, E by H. That is work function by Planck's constant. This question is a question from your NCERT also. It came in 2 times or 3 times it has come in CBSE. Exact, this question. So work function is 2.14. We have to convert it. So 1.6 into 10 to the power minus 19. This will be the value in joules. We'll multiply it to get converted into joules. And then Planck's constant we'll write 6.63 into 10 to the power minus 34 joules sec. So here you can automatically see joules also getting cancelled. So value of energy you will get. Then frequencies value you will get it as by around 5.2 or 5.16 into 10 to the power 14 hertz. This will be the first part. Now see second part. Second part is saying wavelength of incident light if the photoelectric current is brought to 0 by a stopping potential. So stopping potential is given to you. Wavelength is asked. What all data you have? Kinetic energy we did. Remember kinetic energy we did. So you will use a complete relation that we have been using. See, first identify what all things are given. Work function is given. Stopping potential is given. You have work function. You have stopping potential. You do not have the wavelength. So see class, if you can get the total wavelength from this only, E is equal to hc by lambda. Right, from this only, you can, if you use the value of energy, and if you have V naught, so it's not smart if we use half mv square. It's better if we use EV naught because V naught is given for kinetic energy. This is for total energy. And for work function, we already have work function, or we can use h nu naught. We already have work function though. This is work function. So how you write the total Einstein's equation? The total energy will be equal to kinetic energy's maximum value plus the work function. So write down everything. Hc by lambda is equal to, you have Hc by lambda equal to, kinetic energy can be written as EV naught, and work function let us write as phi naught only. You already have the work function. So see class, this was what I was telling you. Main equation is this only. But according to the needs that are given, or according to the data that is given in the question, you will have to modify it. I could have written E as h nu. I could have written E as E only. But here it is V, because we need lambda, total wavelength. So it's better if we write it like this. So from here, wavelength, this will be equal to Hc divided by EV naught plus phi naught. Now just put in the values. This I'll not be calculating, that you can calculate and let me know. 6.63 into 10 to the power minus 34 joule seconds. Speed of light 3 into 10 to the power 8 meter per second. E, electronic charge 1.6 into or EV naught is given. EV naught is given. C class. This is given, no? 0.6 electron volt. See, V naught, EV naught is given as 0.6 electron volt. Right, 0.6 electron volt is given. From this, stopping potential will only be EE will get cancelled, stopping potential will be 0.64. But if it is directly given to us as 0.6 electron volt, here we don't. We'll just put it as 0.6 electron volt only. Or after multiplication, you can multiply. Like 0.6 I have written, after this you can multiply, like 1.6 into 10 to the power minus 19 and 0.6. Now electron volt has been converted. So EV not solved, plus work function was also given, how much? 2.14 electron volt. So 2.14 electron volt again into the same thing. So you can take electron volt common, 1.6 this part. 0.6 into 10 to the power minus 9. See what's your answer coming? You can write your answer in nanometers or angstrom. I think best answer would be nanometer because you will get 10 to the power minus 9 separate. So that will help you convert this into nanometers. So this is how you will solve this question. Note it down, note down the solution. Any doubts if you're having, ask me, I'll repeat the part. Next question, then I'll share.
Ma'am? Ma'am, what is the Planck's constant value?
6.63 into 10 to the power minus 34 joule seconds.
Ma'am, it was minus 11, right? 10 raised to minus 11.
Value of Planck's constant? No, not 10 to the power minus 11. Planck's constant is 6.63 into 10 to the power minus 34 only.
I think I wrote wrong in the notes because in the notes I've written everywhere minus 11.
Okay, then I must have written it there. Somebody else also check. Okay, you have written it minus 11. Oh, it was, I think by mistake, I have only written it. Let me just check. Okay, yes, here I have written. That's why you people have written, no, not minus 11. It is minus 34 only. Okay, this minus 11, no, this is actually gravitational constant. G we have, no, gravitational constant. So that is 6.67 into 10 to the power minus 11. And Planck's constant is 6.67 or 6.63 into 10 to the power minus 34. Please make this correction, all of you. I think that I have written that was gravitational constant's value. This is minus 34 joule second, not minus 11. Please make a correction, all of you. So only Astha could point it out if all of you have written. So now try the second question. All those who have completed the first one. This has one come in ICSE 2003 and once in 2004 CBSE. So see, send me the answers of all the parts. Yes, first part is correct. Second part has some error. Just check it. Others also answer for the first part at least. Either answer in joules only. I think in joules the calculations are very easy. The calculations are very easy in joules. Do not convert it into electron volt. At least answer in terms of joules. Last 2 minutes, then I'll discuss it. Please try to answer, then you'll be able to understand it. Yes, Ahmed, good. In joules, this will be in joules, good. See, photoelectrons are emitted from a metal surface when UV light of wavelength is 300 nanometer. This is incident on it. Now, the minimum negative potential that is required to stop the emission of electrons. This is 0.54. Yes, you'll use the same formula. Good, Fahad. Use it. See what answer you're getting. Formula is correct. So energy of incident photon. So you have to find out total energy. Wavelength is given. Energy you have to find out. One basic formula you have for total energy. That is hc by lambda. This is energy of incident photon. This is not the total entire energy that you will sum up work function or the kinetic energy. This is just the energy of incident photon, and energy of incident photon can be written as either h nu or hc by lambda. Frequency is not given. We'll prefer wavelength. See, class, the calculations are very easy here. Look, this is Planck's constant. Correct, Samaira? Good. So Planck's constant will be 6.63 into 10 to the power minus 34 joule seconds. This is 3 into 10 to the power 8 meter per second. This is 300 into 10 to the power minus 9 meters. See from here, 3, and this becomes 100 only, right? This is 3, this is 100. So you have 6.63 here, and when you solve the powers of 10, this becomes minus 7. Here you have this, so 5 and 8, that is minus 19. So 10 to the power minus 19 joules. If you wish to convert it in terms of electron volt, divide this term by 1.6. Class, when you have to convert joules into electron volt, you divide it. When you have to convert electron volts into joules, you multiply it. Some students were having confusion in this. This is how you convert it. So this will be 6.63 into 10 to the power minus 19. I've written it so close. To convert it, I'll write it as 6.63 into 10 to the power minus 19 divided by 1.6 into 10 to the power minus 19. Minus 19 minus 19 will directly be cancelled. And this will be around 4 something. So 4 point, how much it's coming? That I'll tell you, 4.14. Yes, Ahmed. Good. Your calculations are good. 4.14. See, someone was asking me about 300 into 10 to the power minus 9. No, see, wavelength is given as 300 nanometer. 1 nanometer is equal to 10 to the power minus 9 meters. So if 1 nanometer is 10 to the power minus 9 meters, 300 times nanometer will be 300 into 10 to the power minus 9. 300 plus nahi hai, 300 into 10 to the power minus 9. Okay, so this is the energy in electron. Now maximum kinetic energy of photoelectrons. Class, maximum kinetic energy of photoelectrons emitted. Stopping potential is given. What all data is given? Yes, stopping potential is given. See, stopping potential is given as 0.54 volt. So convert it, what will be EV naught? EV naught will be 0.54 EV. And what is EV naught? This is kinetic energy maximum only. So if stopping potential is given and kinetic energy is asked, then you don't have to calculate even anything. Just put E, multiply E on both the sides. You will get this only. And this term, EV naught, is kinetic energy, so 0.54 electron volts. Finally, it is asking you the work function. Class, total energy, the energy of incident photons you have, kinetic energy you have. Work function calculation is very easy. Third part, Energy is sum of maximum kinetic energy and work function. This has been calculated, this has been calculated, only work function is left. So work function will be energy minus the maximum kinetic energy. So energy of incident photons was 4.14 electron volts minus 0.54 electron. So 0, 1, 11, 6 and 4, 1, 3. 3.6 electron. Just check someone. Yes, 3.6 are in. Thank you. So 3.6 electron volt. This is the work. So when you do it, when you solve it by yourself, this won't take so much of time. Just make your conversions of electron volt and all these easier. And especially if you get stopping potential, try to write it as it is for kinetic energy. Note down the solution, those who have not written it. Then we'll do some more questions. See, that's what I was saying. When you have to convert joules into electron volt, you divide it. Here you had 6.63 into 10 to the power minus 19 joules. So when you are converting it into electron volt, we'll divide it by 1.6 into 10 to the power minus 19. Same way, when you have to convert electron volt into joules, you will multiply it. Like 4.14 electron volt, you have to convert it into energy. So you will multiply it with this term. Then only you will get this term. So this is about how we perform the conversion. Electronic charge, multiply or divide. Divide it for joules into electron volt and multiply it for electron volts into joule. Yes, see, in second one, you know the formula of kinetic energy. Kinetic energy is EV naught. This is electronic charge, 1.6 into 10 to the power minus 19. And this is stopping potential. So if you have the value of stopping potential, so if you multiply it by electronic charge, you will get the kinetic energy. Here we had the value of stopping potential as 0.54 volts. This is just the value of stopping potential that we have, right? Now kinetic energy. Kinetic energy is EV naught. So V naught is 0.54 volt. If you multiply both the terms by the electronic charge, what is this? This is kinetic energy. That will make it 0.54 electron volt. If you further have to convert it into joules, you want to get your final answer in terms of joules, you're thinking electron volt is not needed here. Multiplied by 1.6 into 10 to the power minus 19, you will get your kinetic energy in joules also. Is this clear? Second part to others as well.
Yes.
Yes, ma'am.
Yes, Imad, correct. Answer for the first part is right. Take 1 more minute. Tell me the answer for the second part, wave work function of the metal surface. Now, once you have the answer for the first part, finding out answer for second part is easier. In terms of joules also you can answer, in terms of electron volt answer, you can answer, but mention the unit in whichever unit you are answering. Others also, first part is very easy. This question came once in 1995 in CBSE, once in 2013. Yes, good, correct answer. Fahad, some error. See, let me tell you how to solve this. This is the threshold frequency that is plotted. Right, from the graph, you can see threshold frequency is this. So you just have to identify which value is this. This is not given or drawn not much accurately. This is exactly in the middle of it. So 4 or 5 ke beech mein, if it's in the middle of 4 and 5, what will be this value?
4.5.
4.5, exactly. So 4.5, and here it is written that frequency is given in 10 to the power 14 hertz. So threshold frequency, one liner answer. You all don't have to calculate in the first part. This will be simply 4.5 into 10 to the power 14 hertz. Now, once threshold frequency is there, calculation of work function is not a difficult task. Work function is h nu not only, Planck's constant times the threshold frequency only. This is 6.6 into 10 to the power minus 34, or make it 6.63. This is 4.5 into 10 to the power 14 hertz. So this will be around 2.97 or almost 3 into 10 to the power minus 19 joules. And if you write it in terms of electron volt as rightly answered by Imad, this will be 1.85 or 86, around this much electron volt. Note down the solution, class. Yes, if it is not mentioned. If it is not mentioned, you can write your answers in both joules and electron volt. But mostly it happens, no, like in some questions where work function was given in electron volt. So even when you calculated the total energy in joules, you had to convert it in terms of electron volt. So that you can manage, but this is not fixed that you have to answer in joules or electron volt. Though we all know SI unit of energy is joules, but answering in electron volt is also applicable here because many of the values that are experimentally calculated are in terms of electron volts only. Written the solution part.
Yes, ma'am.
Note down this question first. I think this would be the last question most probably for today. 2017 question. This is CBSE 2000, your board examinations. 2017 question this is. So note it down. A little lengthy portion is there. Questions are below it. Note it down, text me then. I'll show you the question part then. So draw this part, draw the graph, because then it will be difficult for you, to tally. Let me zoom in then.
Ma'am, wait 2 minutes.
No, check your answer. Just check it once again.
Yes, ma'am.
Just check your answer. Written. Someone was writing, no? Zaid, I think.
Yes, ma'am. Yes, ma'am.
Okay. Correct answer. Astha. See, first part is very easy. First part, by just looking at the graph, you'll all be able to answer. Note down the questions first, then one by one you all can answer. At least first part, all of you should answer. Many students have not given a single answer till now. Ahmed, recheck your answer. Samaira, your answer is correct. Others also respond, at least for the first part. Anushka, Eamon, Donna, Jiva, Mariam, Rehan, Wafia, Sakina, Zaid. Second part's, yes, Matt. Second part's answer is correct. First part, did you answer? Answer the first part as well. Answer first part as well. Second part is right, Imad. Ahmed, you're answering for which part, which you're asking? Fahad, Ahmed, both you are right. Ahmed, just tell me which part you're asking. Astha, this is, please mention the unit, Astha. Okay, in terms of joules. Yes, Imad. First part is also right. So second part and first part, both you have completed. Try the last part as well, kinetic energy, because what you needed, you have obtained it from the first part and second part. Now you can answer the final part. Second part, yes, Fahad, good. Second part's answer is correct. See, first part, those who are not able to see, this is the threshold frequency given. Out of these two, you have to tell which is having the higher value. This would be some value, let's say 3.5 something. This is actually 3.5 only, because in the question, no, here was one more marking given. Nothing was mentioned, but it was mentioned like this. So if it is 6, 4, then it would be 2 most probably drawn. So at this middle would be 3. But that is not none of your concern here in the exam. That won't help you. So it's better if you directly write it like this only. Third part answer, yes, right. Second part, good. Samaira, correct. Right, Donna. Yes, class. See, Q will be having higher frequency only, no? These two values are given to you. For the first part, this is one value, this is one value. Even these values, if they are not mentioned, by just looking at the x-axis, you should be able to tell this will be at higher. So the red one, that is Q, this is having higher frequency. So answer for the first part is Q. Now, once you have threshold frequency, you know the value. This value, you know, 6 into 10 to the power 14 hertz. This is threshold frequency. This is threshold frequency. After having threshold frequency, tell what will be the work function. Good, Donna. Anushka, yes, answers by you also. Threshold frequency minimum value. Good, right, Fahad. But see here, one thing. This value is threshold frequency for this metal P. Q is having its threshold or minimum value as 6. This is independent. Let's say this is 3. Let's say this is value is 3. So P is having so many values of voltage, out of which the minimum frequency is 3 into 10 to the power 14 hertz for P. For Q, it's 6 into 10 to the power 14. These are the minimum values for P metal, for Q metal respectively. Now, once you have the minimum values, you are asked to compare out of both of which is the maximum, which is the least. All right. Like if I tell you, if an example, if I give you, NEET has cut off, let's say 600 score. JEE has cut off, let's say 95 percentile, just random values I'm taking. So out of these, if I ask you to compare, so that would be different. This is cut off for NEET. This is cut off for JEE. But if you are asked to compare between these two, got it, Fahad? This is the difference. threshold frequency, if this is just for one metal, then you tell the minimum value. If it is given for, if it is there to compare between two, comparison between two, then you will have to compare it normally using your mathematics. There you won't see which one is minimum. Threshold frequency is minimum, but minimum for a single metal. I hope this is clear.
Yes, ma'am.
Okay. So yes, someone else also answered, I think. Asta. Sahi Asta. Good, correct. I think most of you have tried it. Some students still didn't answer. Please try to answer whatever answers if you are able to do here. If you're able to solve the question, that will help in your, because most of the questions are either from CBSE sample paper, your board examination, the foreign papers that are in your country is available. So from there only. So where if you commit error, no, then you will be able to, like just now Fahad answered, first he answered P, thinking that threshold frequency is minimum value. So minimum is 3. But then now he'll remember that when he has to compare, that will be any normal numerical value. So by this, you will remember from your mistakes. Acha, around 2 you are saying second part's answer. It's not exactly 2, it will be around 2.5. I'll tell you. See, threshold frequency is there. For the second part, we have to determine the work function. Now, work function will be h nu naught, right? Planck's constant times the threshold frequency. So Planck's constant is 6.63 into 10 to the power minus 34 joule seconds, and threshold frequency from the first part is 6 into 10 to the power 14 hertz. So let's do one thing. This you will get it as something 39.2 into 10 to the power minus 20, around this only. So that was, I think, given by Samaira, and Astha answered it in terms of joules. So it's better, let's divide it in terms of electron volt only, 1.6 into 10 to the power minus 19. Now you have the final answer in terms of electron. 2.5, no, Ahmed? Right, 2.5. This will be 2.5 electron. Good. So most of you were able to answer this part. Lastly, I think one student has also answered, Samaira. For the last part, how much you're getting? This much electron volt. Value is correct. The figures are right. Some errors are there in the calculation part. Just see in the decimals. Just check Samaira once again. Last part is asking the maximum kinetic energy of the electron emitted by the light of frequency. So C class, frequency of incident radiation is given 8 into 10 to the power 14 hertz. Work function you have, right? Work function you have. Kinetic energy, you have to find out. One energy is missing, that is the energy of incident. Let's calculate this E as h nu. This will be 6.63 into 10 to the power minus 34 into how much frequency is 8 into 10 to the power 14. This is the total energy that is available. All right. Or let's do one thing, because here this will be subtraction only, no? You can use this also. Frequencies are mentioned. Energy, that is h nu, will be kinetic energy. This is unknown. Plus the work function can be written as h nu naught. We can just substitute it because calculation will be easier. You have the value. Otherwise, divide it by 1.6, get this value and use. So kinetic energy maximum will be h nu minus h nu naught. Take Planck's constant common, take h common. That will be nu minus nu naught. So Planck's constant will be 6.63 into 10 to the power minus 34. Frequency is 8 into 10 to the power 14. Threshold frequency is 6 into 10 to the power 14. Right, calculations are easy. Third, you're getting in terms of, okay, joules your answer. Correct. That's correct. So this will be, or let's do one thing. Let's divide it here only. So get answered in 1.6 into 10 to the power minus 90. So this value, when you'll solve this, the value of kinetic energy will be 0.83 electron volts. You can leave the answer in terms of joule. This is not necessary for you to leave the answer in electron volts, but mostly in dual nature, it is preferred to write in this. Note down the solution. Any doubts you still have, let me know. I'll stop here. Text me done once you all complete the writing part. Yes, Zed, I'll share it right now. Done. Okay. So all those who have completed, you all can leave. You can keep on leaving once you complete it. Some questions are still left, some important questions that I'll discuss on next Saturday now. Okay, so Saturday, same times. Okay, thank you so much, class. Take care. Goodbye.
Thank you, ma'am.
Calculation in the last part. See, 8 minus 6, this will be 2. Here, this part. 6 into 6.63 is there. See, this will be 6.63 into 10 to the power minus 34. And 8 minus 6 will be 2. So 2 into 10 to the power 14 divided by 1.6 into 10 to the power minus 19. So 2 here, this becomes 0.8. So once you divide 6.6 by 0.8, you will get around this value, 8.3. This will be around 8.3 once you divide 6.63. Then C into 10 to the power. You have 34, and this is how much? 14 we have, no? Here we are having 14. So that becomes minus 10, right? Here, minus 34, 14. This becomes minus 10. Then 19 will be there. 19 minus 10, that will be 9. Here this will become 19 minus 10 will be there. That will become 10 to the power 9. Right. Now you are you have already converted to 8.3 into 10 to the power 9 is there. This is in terms of electron volt. So once you solve this, this is see, this will be this is 0.8. Once you solve this, this part 1.6 and 6.6, this becomes 0.8, right? So here when you'll put frequency as 10 to the power 14, and this got subtracted, this became 2 into 10 to the power 14. So this was 0.8 you're getting. Now what all data is left? Just check it. Minus 34, 19, and then you are having 14. So that will cancel 10 to the power n and 14. All these will cancel. 10 to the power minus 1 will be left. This was 8.3. This will be 10 to the power minus 1. So that makes it 0.83. Understood, Fahad? See, I'll write it more clearly. Okay, got it? No, yes, yes. 8.3 10 to the power minus 1, 0. Okay, thank you so much.